for looking through the thing that we have talked about in the past. Hey Subhi, how are you?
I'm good.
Good. So last class, after 10 minutes you dropped off, and I was wondering if it's because I am teaching something in a very scary way, that's why kids have started disappearing. Then mommy told me that you had some meeting.
Yeah, I've had another meeting to join.
Okay. Not a problem. So let's get started. So in the last class, again, you guys will think that this is probably the third class on logarithm, and we might end up having one or two more classes on logarithm, and that's okay, because it's a more scientific way of doing math, and it is not very easy to digest. So it will come with practice. So that's why we are doing more practice, having more classes, and I will not leave you guys till you guys feel comfortable or till I feel comfortable as well. Both have to feel comfortable, okay? So that's why we will continue with logarithm and keep on learning new things. So let me first do one thing. Let me first list down all the basic properties or the rules of a logarithm we have understood or gone through so far. And then we will do some problems to relate to it and to be able to apply it. So when it comes to logarithmic rules, the other thing that we have seen before, log of m into n base b, let me write both in capital letters, log of m into n with a base b equals log of m base b plus log of n base b. This is the first rule of logarithm that we have learned. Everybody is able to vaguely recall this, correct? Datta, Disali, Anika, yeah, everybody. Yeah, yes, Datta. Yeah.
Oh, sorry, I was just trying to.
Okay. Second rule of logarithm or second property of logarithm that we have learned is log of m by n base b is nothing but log of m base b minus log of n base b. This is the second rule of property. Third rule that we have learned is log of, let's say, p log m base b. I'm using the letter b that resonates better as a base, right? So this equals log of m to the power p base b. You guys are able to recall it, right? And the fourth one is, if I have log of a base b, I can convert this into log of a base x divided by log of b base x. So this is the base rule, base change rule of logarithm, right? Where you have log of something to be found against a base, you can convert that to a common base and it becomes log of a divided by log of b. Does it sound somewhat familiar? Relatable? Ipsa, okay? Aryahi? Vishali? Everybody is comfortable, okay with this? Now what I want to do is, I want to see how we can jump onto some problem and see how these concepts or rules are helping us find out the value of things that would have been difficult to find out otherwise. But before we do that, let's look at one last rule where we talked about changing the base. Log of a base b equals log of a base, let's say common base x. Yep. And let's look at how do we convince ourselves that this rule is still valid. Because other three rules that I talked about, we have seen it happening. We have tried relating that with exponents concepts, and then we were agreeing to it. Now, when I'm talking about this rule, how does it sound reasonably right to us? That's what we are trying to figure out. There's so much of silence in the class. Is everybody okay? Surbi, Anika, Disali, Datta, Ariyahi, everybody okay, right? I feel more comfortable when I hear you guys talk. Obviously, talk about things which are related. Okay? So, another thing, the base or the building block of log that we learned was, if I have to find out log of, let's say, A base B, meaning we are trying to find out what will be the value of log of A where the base is B, and let's say if that is equal to C, so in exponent terms we can relate that as B to the power C is equal to A. That's what we have seen. Everybody relates to it? Sure? Now let's come to this, proving this one first, before I make you guys struggle with the actual problems. So let's take one example where we can solve for it. Let's say log of, we are trying to find out log of 81 base 9. Okay? Here you know that, okay, this log of 81 base 9, let's say this is equal to C, then 9 to the power C equals 81. Correct? That means C equals 2, because 81 is nothing but 9 is squared, so C is equal to 2. Okay? I'm not doing it this way. What I'm trying to do is, I will say, so I'm supposed to get 2 for this one, okay? I'm going to use this change of base of log approach. I will say, I will use log of 81 base 3 divided by log of 9 base 3. Should be, am I making sense of that?
Yeah, kind of.
Kind of? No, that scares me. So, that's why there are only two options, okay? I make sense or I don't make sense. Whenever I hear kind of, that gets me a little worried. So, I will repeat myself, okay? So, this is the rule of log which says change of base. Meaning, if you have to find out log of a number against a base, this is as good as log of this number against another base divided by log of this base against another base, and these two bases are common. Yeah. This is the rule log of change of base of logs. That's the name of the rule, okay, or the theorem, whatever you call it. And we are trying to wrap our head around that and see if this actually makes sense or not. Yeah. Meaning, if you have to find out, let's say, log of 5 over 10. As per this rule, it says you can convert that to log of 5. Let's say I'm putting a base 20. Divided by log of this 10 base 20. So whatever you're trying to find log for against whatever base, you can convert this into a fraction form where your numerator will be log of this number against a base divided by log of this number against the same base. Yeah? This Ali, Anika, Ariyahi, Datta, everybody making, is it making sense to you guys or not? So,
Yes.
okay. Yeah. So now, what I'm saying is, if I had to find out log of 81 base 9, as per the basic rule or understanding of logs, we know that, okay, if log of 81 base 9 is equal to x, if I have to find out x, simple interpretation is 9 to the power x will be equal to this. That is how logs and exponents are related. Okay? So here, as per this, 9 to the power x is equal to 81. Or we know that 81 is nothing but 9 square. So this x is equal to 2. This value of this thing will be equal to 2. But I'm not using that rule. I'm just trying to relate that with this change of base rule that we are given. Okay? So here, I said log of this base 9, I can convert that to log of 81 base 3 divided by log of 9 base 3, meaning my base for numerator and denominator both are same. Okay? And we are trying to see if this whole thing gives me a 2 or not. Now look at this. Let's say log of 3 base 81 is equal to, let's say, this only. I'll say d. Okay? So that means 3 to the power d equals 81. Now let's look at it. 81 is 3 into 3 is 9, into 3 is 27, into 3 is 81. So that is 3 to the power 4. That means d is equal to 4. So this whole thing that I assumed as d is equal to 4. Now let's look at this guy. Log 3 to the power, log 9 base 3. If this is, let's say, a is equal to a. So based on our understanding of log, 3 to the power a is equal to 9. 3 to the power a is equal to 9. Now we know 9 is nothing but 3 squared. That means a is equal to 2. So this a, which we assumed as a value of log 9 base 3, is 2. Seems to be convincing. Yeah? So now the deal is, all these properties or the rules that we have learned or understood about, we will have to solve few problems to get more acclimatized to these rules or the formulas or the theorems, whatever you call it. Okay? And the interesting part of that is, it is not about difficulty of the problem. It is about the creativity that we pour in while solving the problems. Let's see how creative we can get. Let's look at some problems. Let's say we have to find out, there's a question that I had posted in this one. Log of 42 base 6. The question says, evaluate the logarithm, round your answer to the nearest thousandth. Ananya. Okay, so Ananya joined and gave me a thumbs up. But the question here is, did Ananya miss something? The answer is not really. Whatever we have done in the previous classes, I just did a recap of that. I just talked about all the 4-5 rules, all the underlying concepts of logs that we have understood or learned so far. And now we are going to apply those concepts for solving problems. So this is the first problem that we are trying to solve. So Ananya joined just at the right time. I don't know if it's the right time or wrong time, but she just joined the time when I was wanting to bother you guys. So this is the first question, which says, evaluate the logarithm, round your answer to nearest thousandth. Let me give you guys some flexibility. Let's not worry about nearest thousandth. Let it be nearest tenth, let it be nearest hundred, doesn't matter. What matters to me is, how would you find out log of 42 base 6? Think about it. Think about all the rules and properties that we have come across so far.
So you do the base is 6, right? So you do 6 to the power what is 42?
But what is the answer here?
So it would be
6 to the power what is 42? So you are thinking in the right direction, but I'm just trying to go a little deeper in that. So what IPSA is saying is, you have to find out this value. That means, let's say this is equal to x, and that x is what we have to find out. It will be the value of this. So what IPSA is saying is, 6 to the power what will be 42. And that's a fair point. Now the question is, how much that would be? 6 to the power 1 is 6, 6 to the power 2 is 36, 6 to the power 3 is 36 into 6, 216. Oh, I am not getting a point blank answer here. I know that 6 to the power 1 is 6, 6 to the power 2 is 36, 6 to the power 3 is 216, and I can just go on multiply by 6 one more. But we know that my answer is more than this, less than this. I mean, my value is more than this, less than this. So meaning my a value, this x value is between 2 and 3. Correct? How would you find that out?
So it would be 2 point something because it comes in the middle of 2 and 3. And it would be less than 2.5 because it's not really in the middle of.
Okay, that's one perspective. Let's hear everybody's point of view. Vishali, Surbi, Ananya, what do you guys think? Anika, Datta, Aryahi. Somebody has to give me some clue. I'm right now clueless. I just have one clue from IPSA. I need more. Vishali, what's cooking up?
I feel like it's going to be a fraction, sir.
It will be a fraction, that is given. That is certainly given. I'm trying to think. See, the clear view that we have is, if it was 6, that would have been 6 to the power 1 and x was equal to 1. That would have been a more straightforward answer. If it was 36, then it would have been 6 to the power 2. So my x would have been 2. But it is not 36. It is more than 36, but certainly less than third power of 6. Yeah? Right? So now, okay, let me show you guys something here. And again, I might not be very correct with what I'm doing because it has more to do with creativity. Now, let me do this way. Can I say this log of 42 base 6 as 7 into 6? Yeah? Or 7 into 6. Okay, so this becomes log of 6 base 6 plus log of 7 base 6. Log of A into B equals log of A plus log of B. This was the first rule that we saw. Yeah? Is it sounding okay? Not really. First rule of log. Log of m times n base, let's say A or B, whatever I showed you guys. This is log of m base B plus log of n base B. You recall this one, right? Should we? Am I making sense, Beta? I'm just getting everybody stressed out.
Yeah.
This makes sense? So same thing here, I had multiplication of two numbers. 42 I can see is 7 times 6. So it is 7 times 6. So this I can split applying the first rule of log as log of 6 base 6 plus log of 7 base 6. Okay, at least I have something better than having nothing. Log of 6 base 6 is going to give you nothing but 1. Why? Because log of 6 base 6, if that is equal to k, so 6 to the power k equal to 6, which is 6 to the power 1, so k is 1. So this whole thing is equal to k is 1. So I got 1 here. 1 plus log of 7 base 6. Okay. Now the question is, we are trying to find out what will be the value of this guy. So here, this is where you will end up scribbling through this to come up with some creative options. Now, look at this. This 7 is nothing but 5 it is little more than 6. 6. Let me see how I can put it. Now let's look at it this way. I'm just thinking how I can make it a little creative option, and you guys keep thinking about it, okay? Ultimately, we have to see how we can get it to the closest possible number that will help me. How do I convert? What did I do here? Log of 6 plus log of 7 base 6. Why did I write it like this? That's what I was wondering. What did I do? Log of 7 base 6. So log of 6 base 6 gave me 1 and log of 7 base 6. Okay. So here, let's try to find. Okay. So here's the catch. So what you can do is, now you can apply the fourth rule. Meaning, let's calculate these things based on power of base of 10. So log of, I can write this as log of 7 base 10 divided by log of 6 base 10. You have to choose a number that gives you some clear view of it. Now log of 7 base 10. There will be a little bit of calculation that you have to do if you are not supposed to use the calculators. So log of 7 base 10, let's say log of 7 base 10 is equal to this time Datta, so D. That means 10 to the power D equals 7. Okay. Now think about it. 7. I'm just trying to find a little creative solution here. Do we have to still go to calculator to find it out, or we can do it without calculator? That's what I'm thinking. Are you guys thinking, or just relying on me for now? I'm just thinking if we have a way to do it without the calculator also. How did you get to number 1.5? Ipsa, you were giving some number, right? That's what I was asking.
So, what I did was, you said 6 to the power of 1 is 6, 6 to the power of 2 is 36, 6 to the power of 3 is 216. Okay. So, what I did, so it would be 2 point something, right?
Yeah.
And I listed out like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I believe that it will be less than 2.5. So that.
So okay, so you are using a number line method to.
Not a number line. It's like I'm doing process of elimination.
Okay.
So I think it won't be 6, 7, 8, 9 on like next number. So and it won't be 2.1. Well, whatever. So I'm like, it will be. I don't think it will be 2.1. It can be either 2.2, 2.3, 2.4, 2.5, or something in the middle.
Something in between. Okay. No, so I'm just thinking, how do I find a more convincing solution for this one? Okay. Let's replace this with 2. I will not use base 10, I will use base 2. Now, okay, let me do one thing. I will come back with a more scientific way of doing it. I'm just trying, kind of running out of ideas to see how I can make this a little more creative. But let me just give it a try once, okay? Log 7 base 2, okay? If I'm talking about log 7 base 2 equal to, let's say, k, so 2 to the power k equals 7. So here if I look at it, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, okay? I'm looking at 7. Between 4 and 8, I'm going from 2 to 3, okay? Between power 2 and 3, I'm going from 4 to 8. So if I'm looking at 7, this 4 difference is resulting into 2 to 3, let's say 10 decimal points, okay? 10 points. So if I'm going to 3, it will be 10 divided by 4 into 3. So I'm going by how many points? 30 by 4, 4.75. So approximately I'm saying that this value 2 to the power 7 to get to, power of k, 2 to the power k, here k, if it is 2 plus 0.75, that will give me approximately 7, okay? This is probably not the most accurate way of looking at it, but I'm just doing some rounding here to give you guys a view. So let me compile it. Let me collate this whole thing and then we will talk about it. I'm just trying to recall if there was any other creative way, but anyways, we'll come to that. We'll come to this problem, okay? I will probably send you guys some solution approach for this kind of situation. First thing first, when you have to find out a log of any number with certain base, what we are talking about is, can we look at breaking this number into smaller pieces, and then if that base gives me a clear clue of how do I find out the value of the individual pieces when I'm able to split it. If it's multiplication, I can my resulting logs will be addition of those things with the common base. If it's division, then it will be subtraction actually. That's my second rule, right? So you'll have to basically look at how you approximate this number, because this question is also saying find out the approximate value in hundredth of to the 100th point, right? So you have to see how granular you can make. Here I took a shortcut. I said, okay, fine. I took a shortcut, say, okay, between 2 to the power 2 and 3, that is where my number is, this 7, 4 and 8, I just split this into 10 points, like on number line. This is 2, 2.1, 2.2, 2.3, and this is 2.10, which is 3. So from when I'm going from power 2 to 3, I'm changing by 4, from 4 to 8. Sorry, by 4 points. So if I'm talking about going up to 3 only, which is going to be like 2 to 3, 10 points is giving me a 4 difference. So if I'm talking about going to this one, meaning instead of going 4 points, if I'm going to 7, what am I saying? If I'm going to 3 points, which is 75% of the total split between these two, I'm getting something like 2.75 will get me to this one. But you have to look at how do you make it more granular to get to more accurate value. Okay? So this might work if I have to go to 100th point. If I have to go to 10th point, I will probably find a different approach. So depending on the question that you're dealing with, you'll have to look at how do you split it out. Hi, Sundara. So right now, everybody is grappling with this to find a solution for this. So let me do one thing. I will probably try finding out some more questions which are more relatable that you guys can try solving it. Okay. So let's look at another one. Let's look at another problem that we are able to relate, at least to one of the formulas that we have seen. Let's say somebody says, find out okay, let's pick up an interesting one. Find out log of log of c base 2 times log of c base 2. I am trying to multiply this log of c base 2 with log of 2 base c. What will that become? Any idea? Let's do it. So are you guys super confused or worried right now, or you're ready to give it a try? So Vasundhara, since you joined now, what we are trying to do is we just need a quick recap of what we have learned with respect to properties of logs, or the 4 rules that we learned in the previous classes, and we are trying to apply those concepts for solving problems. So we are trying to find out what will be log of c base 2 times log of 2 base c. And my only message to you guys is, these are all creative problems, because they know nothing complicated about it. We just have to look at how we can get more and more creative while solving these problems. Let's look at it. Log of 2 base c. Let me solve one for you guys, and then you guys can solve few more. The 4th rule of logs, change of base, that we have learned is, if I have x to the power, we have to find out log of x base b. This will be as good as log of x, let's say base a, divided by log of b base a, meaning I can convert this into a fraction form with the same base. Yeah, where your numerator is log of this one and denominator is log of this one. Yeah, so if I apply this here, see what happens. So this I can convert to, let's say, log of c. Let's pick up a random number, log of c base 5 divided by log of 2 base 5. Correct? Can I do that? And this guy also, let's say, I will pick, let's say, let me pick 8. I'm just purposefully picking, or let me pick 4, okay? I'm just trying to be a little creative here. I'm picking a number which comes with the power of this one, because I see 2, right? So I'm picking up a number which can be converted into power of 2, okay? So log of c base 4 divided by log of 2 base 4. And this one again I'll pick the same base, log of 2 base 4 divided by log of c base 4. What happened? Log of c base 4 and log of c base 4. Same thing. Log of 2 base 4, log of 2 base 4, same thing. What did we get? 1. Yeah? Not convinced. So see this one, I had to find out log of something multiplied by log of something. What we saw was, in this case, the number for which we were trying to find out base log was c, and here for the second one c was my base. So I am applying the 4th rule of log, which says I can change the base. I can convert this into a fraction form putting the same base.
Okay,
so I randomly picked 4. 4 is my base. I thought, no, tomorrow if I get stuck, not tomorrow, today if I get stuck here, at least I'll be able to convert 2 in terms of 4 with the base 4. So this here and here both places, since I had 2 as a number, here as a number to find the log for, here 2 as a base for this log. So I chose 4 as a common base, and I could convert this into log of c base 4 divided by log of 2 base 4. And this one again I chose the same base, and that flexibility we have. We can choose any base that we want. Only condition is it has to be same. Okay, so here this became log of 2 base 4 divided by log of c base 4. Now what we are seeing is log of c base 4, log of c base 4, log of 2 base 4, log of 2 base 4. All that will cross each other and the answer is 1. So if you, I know it takes a little bit of switch for all of us, including me as a teacher, right? I mean, I was also trying to find out something creative for the previous problem, and I did not get the idea. Instead of making you guys wait or me myself going to find it out, that would have been a waste of time. So that's why I thought, okay, I will not make you guys struggle because of my lack of creativity at this point in time. We will come back to this one. But net, what I'm trying to say is, all these properties of logs that we're talking about, that we have talked about, as long as we can think of some creative ways of relating them or applying those, it will become a little easier. So let me pick up another problem. Let's say this time I want you guys to find out log of 8 base b divided by log of 2 base b. Okay, log of 8 base b and log of 2 base b. How much this would be? Let's see, what did you get? What you guys are getting by attempting this problem? Are you guys ready to try it? Datta, Disali, Aryahi, Surabhi, Ananya, Vasundhara, Anika, Ipsa. Okay, give it a try. While you guys are trying it, let me quickly check what is happening with the previous problem. Yes, Dutta, what did you get?
Sir, I got 3.
You got 3. Okay, let me see what everybody else gets. What did you get, Aryahi?
I also got 3, sir.
Okay, let's see if Datta and Aryahi both are safe, or there is somebody in the class who can challenge them.
I think it's 4.
You think it's 4? Okay, good. We have some variation among the answers I'm getting here. Let's see. What are Vasundhara, Anika, Ananya, Surabhi, Disali? Yep. What did you get, Surabhi?
I got 3.
You also got 3. Okay. I was just, while you guys are attempting this one, I'm just trying to find out what is the right way to look at it creatively. Okay. So let me give you guys some surprise. But before that, so how about Vasundhara, Ananya, Anika, and Disali? You guys are very quiet. What did you guys get for this one? Anika is thinking. How about Ananya, Vasundhara? Yeah, Disali.
I think it's log of B.
Log of B. Okay, so this is an easier one. So let me see, when I have a situation like this, always remember you have this thing common here and here both. So if I convert this into, let's say, since I have 8 and 2, right? What I will do is I will use 2 as a base for all of them. Okay, meaning when I am converting this guy, log of 8 base B, I will convert this into log of 8 base 2 divided by log of B base 2. Is this part okay so far? Anika, Vasundhara, Nanya, everybody okay, right? Datta, Yahi. So what I'm doing, see, I'm trying, this one is more about creativity and being lazy. I'm trying to be lazy, I'm just trying to avoid any calculation where I can get stuck. Yes, Datta.
Sir, why would you turn the 2 into the B? Because can't we just use the subtraction? I forgot what it was.
No.
The fourth rule for this one? Because the B is common in both of them.
So I'll come to that. We'll explore that option also. Okay. We'll explore that option too. Okay. I'm just going by the properties we know. So I'm just trying to, when I looked at these two, the first thing that clicked to my mind is, okay, 2 to the power 3 gives me 8. So what I can use is, I'll use the smallest number as a base for converting into, or using the base conversion rule, okay, for the logs. So here I'm converting into this form using base as 2. I'll come to you, Datta, okay? That option also we have. You are thinking in one direction, and again, this is all about how creative you can get. Now, this is my numerator, which I got as this. Now let's look at this one. Log of 2 base B. I will again use base of 2 as a common base. So log of 2 base 2 divided by log of B base 2. Yeah. Applying the fourth rule, this is what it is. And we are trying to divide this by this. So I will say we are trying to divide this. Log of 8 base 2 divided by log of B base 2, and this is to be divided by this one, which is this value. So log of 2 base 2 divided by log of B base 2. And this guy will flip, it becomes log of 8 base 2 divided by log of B base 2 multiplied by, this guy goes up, log of B base 2 divided by log of 2 base 2. So this one and this one are same, you will do tic-tac-toe. Now you are left with log of 8 base 2 divided by log of 2 base 2. Log of 8 base 2 is, let's say, x. That means 2 to the power x is equal to 8. That means your x is equal to 3. 2 into 2 into 2 is 8. So if this is log of 8 base 2 is x, I got the value of that as 3. Similarly, log of 2 base 2 will give me nothing but 1. So answer is 3. Did you see the difference? Now going to Datta's point. Datta is saying, why are you trying to waste my time? I can do that little faster. But before I go to Datta's approach, are you guys okay with whatever I did, or you found something complicated here? Surabhi, Ananya, Vasundhara, Anika, Aryahi, Ipsa, everybody okay? Now let me go to Datta's approach. And again, there is no boundary, there is no limitation. It's about doing the calculation. Let's see. Let's say this one is log of 8 base b is equal to, let's say, this time I will use whose name? Vasundhara's name. So v, let's say this is v. That means this is b to the power v is equal to 8. Okay? Now if I look at this, log of, this is my numerator, okay, which I gave as value v. So this is my v, and from that I found some relationship. B to the power v equal to 8. Now let's say log of 2 base b is equal to, let's say, ipsa. So I'll put I. Okay, that means b to the power I is equal to 2. Okay. So now you look at this one a little carefully. B to the power I is 2 and b to the power v is equal to 8. Can we draw some correlation here? This is v, Vasundhara, the numerator, and this is ipsa, denominator. Okay. Now what you are seeing is b to the power I equal to 2 and b to the power v is equal to 8. Let's just randomly put some value. Let's say this is 2 to the power 1 and this 8 is 2 to the power 3. Both can have the same denominator. I mean, both can have the same base. When 2 to the power 1 is b, 2 to the power I, that means ipsa's value is 1 and Vasundhara's value is 3 over 1. So I'll let you guys always choose which approach works for you. Okay. This one uses one concept, second one uses another concept or property. You have both options. Does it sound okay? Datta, is that what you are referring to?
Yes, sir.
Surabhi, Ananya, everybody okay, right? Aryahi?
Yes, sir.
Okay. So let's go to the next problem and see. Okay, so I was coming to the other point, okay? That problem that we were dealing with, what that tells us, okay? I was trying to find out, let's say, what is the value of log of 1 over 5 base 10. Okay? If you have to find out the value of this one, what will that be? What we are talking about is log of 1 by 5. I can write this as 5 to the power minus 1, right? I can make it go up and this is what it becomes. Is it sounding okay so far? I'm juggling between the basic exponent understanding and logs, and you have to be equally comfortable with both of them. Okay? Yeah. So 1 by 5, when I was trying to find out, I can do it like this, or I can say I will write this as log of 2 base 10. Does it sound okay? Now, when I am talking about this, log of 2 base 10, I can break this as log of, what am I doing? No, let me not go that route. I can take this approach. Now when I see a power here, we know one concept, that is P times log of A base B equals log of A to the power P base B. So as soon as I see a power here, this guy can come to this side. Okay, so it can become minus 1 into log of 5 base 10 as per this rule. I'm not seeing so much of comfort among you all. Are you guys comfortable so far? So when I have a multiple to a log, this coefficient becomes power. Or if I have a power, I can make that as a coefficient and I can deal with this. Okay? But what I was talking about was, when I was exploring this, okay, it says that when you have a situation like this, there are some very commonly used log values that you will have to either memorize or use calculator for this. So something like log of 2 base 10 is 0.301. So what it means is 10 to the power 0.301 will be equal to 2. Okay. So you'll have to memorize this. That's what it says. Or else you have to use calculator. Now when it comes to using calculator, in the calculator you have only two options. You have, this is what I was explaining in the last class also. You have two buttons, okay? One button is called log and another button is called ln. When you are using the button log, you are talking about this. When you are using the button ln, you are talking about log base e, where e is another number like a pi, which equals 2.711818, it just goes on. So when your base to the log is e, that is when you will see a button ln in the calculator. When you are seeing a base of log 10, when you are pressing the button log, you are talking about base 10. And that is where when we are talking about this one, when you are trying to calculate this, what you have to do is always find out ways to convert your log with a calculator friendly base, either 10 or e, and for doing that, for changing your base, you have to use the base conversion rule, okay, base conversion property, and then you can find out the log for, in this case, once, let's say, let me put another question here. I think now I will make little more sense than before, okay? Are you guys ready to listen to me? Alright, are you ready? Now let's say, if I say find out log of 49 base 3. Your first attempt is always going to be, is 49 a straight power of 3? Interestingly not. So then you cannot do it by simple calculation. What you will do is, now you have to rely on the calculator. And calculator understands only two languages, or two formats. One is base 10 or base E. It is up to you which one you like. And you will say, okay, fine. I will rather convert this into log of 49 base 10 divided by log of 3 base 10 using this property. Now I will take my calculator out and then say, okay, 49, what you will do is you will press 49 on your calculator keypad and then press the button log. It gives you the value of this, whatever it is. It might give 10, okay, it's not 2, it's certainly more than 1. Let me make it up. It says 1.417. Okay? I'm just making it up. Then same thing. You will say, okay, you will press 3 and then press the log button. And it gives you 0.477, I guess. So log 2, log 3, log 4, log 5, log 7, these are, when I was kind of referring to it, it says you have to memorize the log value base 10 for 2, 3, 5, 6 and all that. I would not go that route. It will be easy to forget and a perfect recipe for disaster. But for your Algebra 2 exams, you will have the option of using calculator. So you are better off applying this concept of changing the base of logs and then using a calculator to find this out, and then you know what calculation to take it. Does it make sense? Sundara has not said anything to me today. Are you okay with her? Anika okay? Disali?
Yes, sir.
Ananya? So while I always prescribe or prohibit you guys from using calculator, but a situation like log, you will not have that option probably. You can be creative to some extent. Let's say if somebody says find out log of 243 base 7. Okay, you will see if you can break this into small as a power of 7, or change this into a smaller number with some power, and which is common as a power for this guy also. If that is the case, wonderful. If not, you will look at, can I use the log division formula? So log of m by n base b is equal to log of m minus log of n. So this is second formula. Third formula is obviously the power thing. I mean p log something equal to log of a to the power p. So you'll have to look at which way you want to proceed. You have to first try your simple breakdown, multiplication division approach. If that doesn't work, check the power. If that also doesn't work, then you are leaning on this third option. You will say, okay, fine, now I give up. I will use the same base, use 10 as my base or e as my base, and then use my calculator to find it out. That would be your 3-step investigation that you would do for finding out the approximate value for the logs. Does it sound okay? No? So we are almost at the time. I will just give you guys one quick riddle to solve, and I want to see how you guys are reacting to it. And try not to solve this, okay? Try not to solve this. Get the answer without solving it. And you have to find out value for log of t divided by log of t base 8. So here you don't have a base. You can choose the base of your choice. And the options you have are log of 8, log of t square base 8. Option C is 1 by log 8. And option D is 1 by log of t square base 8. So I'm just wrapping up the class for these kids, and then we'll start the pre-calculus class. Hey, Anna. Okay? Yes, Disali.
Can you repeat the question again, sir?
So we have to find out log of t divided by log of t base 8. So here you don't have a base, you can assume base of your choice. And here are the 4 options that you have. What I'm saying is, can you guys find out which option looks to be right with calculation or without calculation?
C looks right.
You think it's C? Aryahi, Disali, Shilvi, Datta, Vasundhara, Anika, anybody? Which option seems to be more right? C? You guys also all aligned towards C? If so, I told C, I'm not sure. I'm trying to find it out. Okay, so let's do that in next 2 minutes and then we'll let you guys go. Here log of t. What I will do is I will use the base conversion formula or concept or theorem, whatever you call it. Log of t I will write as log of, let's say, 10 base t, or let me put 8, let me use 8 only. Log of 8 base t, what am I doing? I'm using, let's say, yeah, this is, what was the question? Log of t, okay, yeah, so log this one, so I will use 10 here. When you don't have anything here in the base, you can use 10, and this is log of 8, log of t base 8, so you can convert this into log of t base 10 divided by log of 8 base 10. So the denominator you can convert into log of 10, log of t base 10 divided by log of 8 base 10. And then this guy goes up and this one remains below. So it becomes log of t base 10 divided by log of t base 10 into log of 8 base 10, or you can convert it to log. So these two will be gone. Actually your answer will be this one. I know this was a little bit of a ride because logs are not easy to digest, but remember one thing, you will only use the basic concepts or the properties that we have talked about, and then once you come to a point where you have to choose your base, you will use the base conversion concepts and then use the calculator if you are not able to find any creative solution for things. Okay? So with that being said, I will let you guys go. I already stretched your class for 4 minutes. So, yeah? Alright, that is here? Yeah. Okay, alright. Bye everybody. Bye bye, bye bye.